Okay, so today we're going to make a utility for the ES-8, and the ES-8 is this module right here by Expert Sleepers, and what it is a audio interface, and you have 4 inputs and 8 outputs. And what's so cool about it, though, versus a normal interface, is that it's DC coupled, which means you can send audio signals, control voltage signals in and out that are DC offset. So usually in a normal audio interface, when you have outputs especially, they will remove any DC offset. So like if you have a static voltage that's hovering at 5 volts, say, you don't want that static offset going to your speakers, because the speaker will be pushed out or pulled in all the time, and it'll eventually damage it. So but to have your control voltages come in from your modular or go out to your modular from Audulus, you have to have this DC coupled. And so right now, what I have going is I've got 4 inputs here from different oscillators. So I've got 2 oscillators here coming from the data, the Mordax data, and then I've got one here that's coming from off screen, and this is here, I'll show you there, a self-resonating filter over here, and that's coming through to here. Then I have the oscillographic block, and what it's doing is I have an end of cycle trigger that's going back and triggering the sound, and then I'm taking the envelope out here, and it's just, to have an example of an envelope or something that's coming into these. And so the utility I want to make today is going to basically just do simple math with these signals together and then put them out into these outputs. And so if we go on the screen here, well, first I'm gonna go down here. I'm gonna turn these so that they're slower waves, so we can actually see them in Audulus. And we have 2. Let's see, C4. Turn that down. Down. Okay, I guess 16 is as low as that goes. So we got a sine and a saw wave there, and I can go here to the new. This is ADC, or analog to digital conversion node, and I'll go to the waveform, and here you can see that looks like this must be this wave up here. Looks a little odd on the scope here, just because I'm running so many graphics things at a time, and it's having a hard time drawing everything accurately. 2. Why is that not coming in? Okay, that must be. Yeah, there we go. Okay, so I guess this one, it's a little slow. This is the self-oscillating filter. This must be this is the envelope coming from the oscillographic block, and it's I think it's like an 8-bit envelope, so it's got might have some smoothing to it, but still okay. Adjusting. Get a stronger signal off of this. Clean. Okay. What am I doing wrong here? Okay. So we'll just have this be like an audio rate oscillator. Do that. Oh, come on. Stay there. Like I said in the previous tutorial video, this isn't 2 waves here. It's just averaging the wave. It's too fast to draw. So this is 0 going across here. This is 1, and this is -1. And so it's a little offset to the negative, which is typical for a filter. And yeah, so that's the drive function that's moving it up and down. So we got 1, 2. This is input 1 and input 2 here, 1 and 2, and then I'll have the 3 and 4 come from the 3, 4 come from the Mordax. There we go, a nice clean sine wave, and then that's the saw wave. So there's all sorts of things we can do when we combine waves and envelopes together, and we can do those through math functions. And let's see, how do I want to do this? I can do stuff like, let's just do simple multiply. So got 1 by 2. have that go to DAC, have that go to output 1. And now you can see here this started this kind of pink color, and that's just oscillating really quickly back and forth between positive and negative, and that's why it looks this pink color instead of a red color, kind of like here. I don't know if you can see that. That's the envelope there. And this is a combination of the envelope and the filter oscillator. Let's do it this input and this input so we can see it flashing a little slower. There we go. So you got this sine wave that's going up, positive and negative from the data over here, and then we have the envelope that's it's getting multiplied by, and we can see what this looks like over here, like this. So you can make a complex signal just by multiplying things together. So that's a simple multiplication. If we add them, do this, add, make this go to output 2. So it's going off the scale a little bit, and it's probably clipping the signal as it's going up. So I'm going to shift it down, and to do that, hey Nick, whether Audulus can take advantage of the various ES, yes, definitely. So you have up to 16 inputs and outputs currently. In the future, it'll just be arbitrary. You can have as many inputs and outputs as you want. You can make big aggregate devices. At the moment, though, it was just easy to fix it at 16 to get the update out. So yeah, even though I don't have the expanders, you can definitely expand to use those. So, all right, I'm going to have a knob here. This will be kind of an offset. I'm going to multiply this knob by, let's say, times 2 plus -1. And then what that's going to do is, if we look at the value here, it's at 0 in the middle, and then -1 and -1, or plus +1. So I can shift this by doing this. So let's shift it up, I'll shift it down. There we go. So that's alternating more around 0, and you can see flipping there. Yeah, data is the best. Okay, so didn't have any plans for this module other than just doing something off the cuff. So you might see me wondering what the best arrangement for these things are. So let me see. I could do. Let me get rid of these. We don't need these right now. Whoops. I'm going to do, for each input here, we'll have a switch. So I have the mux. I'm going to have 1, 2, 3, 4. I've been trying to convince Taylor to swap these around so it goes 1 through 8 this way rather than 1 through 8 this way. It's just kind of the way that it started with, but to me it makes more sense to go 1 up here and then go down, just the way I read stuff. So then we get that, and then I'll get a knob here, multiply, switch these around, the select, and then we have, remember this starts at 0, so it's 0, 1, 2, and this starts at 3, but if I've just put it to 3, right here, then it will only switch to 4 at the very end when the knob is just all the way up. So to fix that, you just have to add 0.99 at the end, and then you'll get a sweep where this portion is the 4th input, and this one's the 3rd, 2nd, 1st, like that. So let's do this. We'll group this into a little, just to keep it clean. Group that in. Edit there. And then actually, yeah, that way I can have them come straight across. And then of course you can go to the knob, and when we make the module pop out to the eventual, encompass all this stuff, we could just put another knob and attach it there like that. So you know what we're gonna have? Let's have another output here. Oh wait, sorry. Design my own mux nodes. Yeah, definitely. So I'm gonna have a number that comes out of here, a number signal that will say what input is being selected. So I'll go in here to this module and do it. There's another mux, right? Yeah. And then I just do 1, 2, 3, 4. Value. Oops. So now, wait, we can put that on the outside. And I know this is the number output because this is the signal as it's going through. It's already still attached. Metering value. Whoops. I'll lock the UI. Do that. So 4, 3, 2, 1. That. And so let's put this to the side for a second. All this stuff go down there. And what I want to do is I'm going to have these two of these, and add that there. So if it's 4 times 4, it's squared, the input, and 4 times 3, you get the FM right there. See that? 2. That's the saw wave off the Mordax. Then 1, that would be the sine wave, or sorry, the envelope. Okay. Cool. So this is selecting those two. I have another knob. Attach that there. Attach that there. So what kind of module is this? So each of these, like, so output 1, I'm going to say, output 1 is one of these signals multiplied by each other. And I'm going to have another output that's like these two signals added together. And then another output that's like, I don't know, 1 to the other's power or something. I was just kind of wing it as I go along. So if I want to keep these out of this patch that I'm going to create that'll suck all these in together, then I just have to move them away. Put this here, and you know what? Yeah, I'll disconnect these. Yeah, go ahead. Robert, that is. Go. You can send suggestions. You can have multiples of these inputs and outputs. So I can just make this the whole multiply thing. So group. Boom. And this is just to keep things like, it would get messy if I was doing everything with the same inputs and outputs. So let's group this again, and then this will be the subpatch that everything is in. Expose these. And I can tell this one is the second one and this one's the first one. UI. Okay. Post them on the forum. Wait, you can post them here too. So it could. All I have planned right now, I guess, is mostly the addition and multiplication. So, how do I want to do this? Could do something like this, 1 times 4. Then I'll put a little times text point in there. Higher value overdrive? Is that overdrive? I'm not, can you explain that a little bit? Okay. Okay, well, I guess I'll take a look at that later. Okay. So now that I've made this thing, it makes it really easy. I can just go copy and paste all this. And since I want to separate these knobs from each other, like put this one down, put this one a little bit up, and then I know this is 1 and 2. And then I can tell also that wave's going to look different. And then unexpose, expose, unexpose, expose, edit, turn that into a plus sign, go into here, set that to channel 2. Oh, excuse me. Wait, I confused these. What was I just doing? Okay. Those are the values. So I go to the add. Boom, boom. Just replace it there. So now this is adding the signals, and that's going to output 2. Let's see that there. And okay, so I pop back out. Edit UI. So that's this one. There we go. Replace those. Plus. One plus 3. Oh, whoops. Lock UI. 1 times 3, and then 1 plus 3. So you can see how those are different when we add, or multiply or add them. And we'll make this the same. There. You know what? I should probably, I'll put a little voltage guide on the side. That'll be useful. So I'm going to temporarily take this out. I'll put 0.5 here, or sorry, just a 0. So it'll draw the line across the middle. And move all this down here. Expose, expose. Cool. So 0 volts. -10 volts, and then -10 volts. Also, I guess we'll go ahead and just put a 5-volt one there too, because I guess a lot of modules use 5-volt power. Whoops. Let me see what I do. I'll get rid of this. Yeah. Okay. 0 volts. 5 volts. Okay. So to have 1 there, and then that's where 10 volts is, because the output of maximum output of Audulus is negative 1 to 1. So when this is 1, and then the maximum output of this is 10 volts. So if I have 1 in Audulus, then this will be maximum positive. And then if I have -1 here, 1, that's 10 volts. Move this stuff down. And put those in the middle. Check how middle they are. If we go 0.5, yeah, that's about it. That's close enough, right? And -0.5. There we go. Okay, so now we have a voltage display for the oscilloscope. There. Okay, so what should we do next? We gotta space these out. And see, I don't like putting knobs too close to numbers like that, because then they'll get covered up by the knob when you pull it out. So pull this down a little bit. Put that up there. That's good. Okay. We'll do the same thing over here. And see, I can just really quickly copy and paste that stuff, and because it doesn't really matter which one is which, I usually just go and just pull them down, even though this is technically the one that's associated with this one underneath the patch. Doesn't really matter. Okay, so I'm going to do the same thing here. Well, actually, what I'm going to do is I'm going to put the 1 there first, so I can, and then I'll do -1 here, so I can see how close they are together and match them up like that. Okay, put that there. And then do -1 here. Oh, Abstract Cats. If you just have Audulus 2 right now, we're pretty much giving like free upgrades to people who have Audulus 2 just because they're stragglers. So come along, and if you have Audulus 2, just email me and I'll get you, at some point I'll get you a working on Audulus 3. You know, especially the people who had the Windows version, they got a free upgrade because when Windows came out, it was just shortly before version 3 came out. So I didn't think it was fair to make them, you know, all of a sudden have to pay for another upgrade. There goes that one. And then -0.5. Okay. There we go. Lock UI. Oh, and I have to go back in, attach that. So, but I wanna add an extra control here for that offset. Just because when you're multiplying things together that are within a range, they're not going to. Well, I guess they would. Yeah, if you're doing 2 offsets. Let's add another offset, or this one will be these are going to be the 2 selects. This is the thing about I really do want some better, Taylor and I have talked about better options for moving things around, like instead of having to move everything individually. Cool, yeah, just hit me up at here, I'll write my email here. Right there. It'd be nice to just be able to, if I could somehow select, just like I can in, you know, a lasso select, I would love to, within this patch, select all of this stuff and be able to move it around all together. So I could do, yeah. That up one. I'm just checking to see if it's still within range. And then lock UI. And what I'm going to do here is I'm going to add a level node here. Actually, I can just go my favorites. Is this the right one? No, I don't want this one. Yeah, definitely. Okay. And so this is sort of like a multiply. You know, it's multiplied by 1 or by 0, halfway in between. Then I want to grab that offset. Wherever was that? Did I delete that? No, there it is. So I cut that, and I'm bringing it in here. And I'm going to paste it. There it is. So I delete this stuff. Right there. Right there. And I'm just doing this really quickly. Usually I would do some kind of nicer UI for things, but this is just a quick and dirty job. And output. And like the other live stream, this patch will be posted on the forum for you to play around with when I'm done. So lock that one. Whoops. Put it there. Put output. They're not there. So this is the add, subtract knob, and then that one's the multiply. So I do that to tell the difference between the two when I pop out to the front panel. And oh, I guess I could just do this. The input. Now when I usually do this, actually, since I'm going to delete the input name, I'll just delete one, and then I know that that one's this one, like that. And make two more knobs here. Make one be, oh yeah, like instead of, I mean like another module like this one's multiply, this one's add, and then one of that logical expression there. Is that what you're saying, Robert? Excuse me. Okay, cool. Yeah, I got you. Let's clamp this output too, actually. We clamp x -1 to 1. It's going to do that anyway. When it's coming out, it's not going to be able to go beyond 1, but it'll just look nicer on the meter. Instead of just kind of going off the screen like this is doing right here. So I'll label this. Well, we don't need to label these ones because we know when we turn them, we see this moving. So let's label this one add, multiply, and then unexpose, expose. Oops. Down here. Whoops. Forgot. So I know these are the other knobs that are in the same position they should be, and then these are the add and multiply. So there. I guess let's make them like this, or maybe this way makes more sense. Yeah. That one times. Okay. And then we see I can use this to offset the voltage and attenuate it. Ah. Oh, whoops. I accidentally locked it. Do that. Actually, I should make this into 2 so it'll have more, so have some gain. Go inside there, or we'll make this 4 and -2. So it'll go in between 2 and 2. Okay. I guess, is that... Ooh, that's why. It should go the other way. This one should come first. Then this one. Okay. Yeah, that works better. And just switch them around. So there's little UI stuff like that, like, you know, most people read left to right, top to bottom, and when you're building a UI, you want to have that reflect what you're doing. So, like, you know, this makes sense that that's that number underneath it. You can, when you turn it, you can see the number change, and I don't need to put a little label here because it's discoverable. Like, as soon as you turn it, that's what it is. When you have knobs that are there's a signal flow underneath, you usually want to do, you know, left to right signal flow, so you know that the positive comes after, or the offset comes after the attenuation. There we go. That works better. Cool. So this is how I like it now, and I'm gonna go, and you know what? Yeah. I'll do this. So I'll start making this module again. That. So I can tell this one's in line with the 10 volt, so 10 volt down there. It's got a line there. I think that's off. Is it? I can't tell. 2, 1, 2. Usually go, so like that's right underneath, right on top of it, underneath. So that's 1, 2, 3, 4. Go 1, 2, 3, 4. And then that's how I can tell that they're the same distance away from each other. There and there. That looks better. Okay. Looks good. And I'm gonna go in and basically, instead of doing everything that I did in here into here, I'm just gonna copy and paste that again. Basically, just redo this there. Take these there, and then all I have to do is change that to an add. There's an add note there. So now this is add again, but it has these extra features. Okay. So I know in general, like when you create some new knobs, the old knobs are underneath the new ones, so you just move those out of the way, and then these are the new knobs that are down here. Okay, so lock UI. There we go. That works like it's expected. Cool. Again, you can see it should be responding. That doesn't look like it's. What am I doing wrong here? That doesn't look right. Oh, man, I must have messed these. I messed these up somehow. Okay, these ones are the ones that are on top. No? What's going on here? If anyone has any ideas, like, what am I doing wrong here? This happens more times than I'd like to admit. Oh, yeah, duh. I forgot to change that when I copied and pasted it. Now it should work. Okay. Yes. Okay, because you can see this should be red and then blue. Red, blue. Okay. So if we set this to 0.5, then we know that's no offset. And then if we have this all the way up, then there's no attenuation. Okay. Cool. So, oh yeah, what was the next one? Excuse me. We're gonna do a gate on the next one. I have all this, copy and paste all this stuff. And just to distinguish this, turn those down. Okay. And expose, expose, and then that'll bring those down there in this little part. And there we go. What do we want to do here? I want to do the thing that Robert was talking about with, what was it? This expression right there. So B is greater than A, B otherwise than A. Okay, I see what you're saying. So move this. And then this one's going to go to 3. Set that right now so I don't forget. And Robert's talking about we do an expression here, expression node, and basically so if input B is greater than A, then output B, otherwise output A. So A, B. There. Cool. You can see that. Let's offset a little bit. Yeah, well, so what I'm doing right now is this is to abstract cats down here. What I'm trying to do is create an all ES-8 module, so that say you have yeah, I did. Yeah. You could load this patch that I'm building onto your iPhone, say, and you plug your iPhone in here with the camera connector kit, and then that turns this into like a math module, basically, that you can have all of these inputs, and then you would just know, okay, this is the multiply one, this is the add one, this is this logical expression one, and you can use the phone as a display for this stuff, or you could just set it however, and then you just want them to multiply, and you could set the phone off to the side, up on top or something, so you don't have to necessarily interact with the phone to use this as if it were a module. There we go. Does that make sense? Abstract cats. I have a whole series of these modules that I'm building with the help of people like Robert Siret. Is it Siret or Siret? But I've never said it out loud, actually, now I think about it. Where you can basically turn this into a module by itself. So I've got some other ones that, I've got an octature LFO, where this is, 8 different sine waves that come out, and then you can spread them out in their phase relationships to each other. And then these 4 inputs are actually CVs over the LFO that come in. So you could have, the speed, the spread of the LFOs, and some other 2 things that I forget. Pirate. Cool. Nice. Alrighty. What's going on there? Oh, yeah. Divided. There we go. One down there. And this one there. There. And there. Oh, and got these. Okay, so if I did this right, yep, that will translate that one up and down. Oh, and of course I needed to do the spacing here. There we go. Is that right? -10. It's a little further down. It's there. Yeah, that looks right. Okay. Then 5, 0, -5, -10. And then these ones are going to come down. I put instead of labeling the knobs like, a lot of people do, where you can go underneath the knob like this and rename, and then that'll appear directly under the knob. I like putting them in the middle, it's an aesthetic choice, purely. Like it also allows you to group the knobs closer together, which is nicer on smaller screens. So much to learn for me. Cool. Yeah. So I mean, well, you want to make some hardware synths. This is kind of like the start of it, where you can make a synth in Audulus and basically get one of these, or ES-3 or whatever, and you like treat this as if it were the synthesizer. So you could have the volt per octave stuff come in here. You have the audio come out. Do different CV stuff, envelopes. So you can like pretend, basically like you're writing your own DSP hardware for this stuff, or DSP software. And eventually, I'm really trying to convince Taylor to do some kind of like Raspberry Pi or another small, like affordable computer where you could build a patch in Audulus, load it onto that thing, and then like put it in a box and sell it as a synthesizer, like a, it would be just, excuse me, as a reel of a synthesizer as if you'd written it in, other DSP code and, in C++ or whatever, because that's really what's underneath all this stuff. When you're playing around with all this stuff, you're really just writing C++ code. It's the easy way. Okay, that looks good. I think this is... Nope. That's right. Okay, what do I put for the symbol there? Maybe... Yeah, we'll just do the Oh, whoops, I put these too close. Of course. See, again, this is one of those why I want that lasso select. Because I don't have to just move all of this stuff down in one group. That looks right. And I'm switching back, if you don't know, I'm switching back and forth between the edit and lock UI modes, because to manipulate things you need to turn the knobs. You need to have it locked, and then to move elements around on the UI you have to enter the edit UI. And of course now I've mixed these up. So, is that right? Okay, so it's just the numbers that are mixed up. Yeah, okay. Cool. It's kind of a neat one. You know, because then I could take this, you know, take a CV out here, and then pull it over here into the oscillographic block, and then have it to any of its CV inputs here, or even say, you know, like the CV down there or down there. Okay. All right. Any ideas for the next one? Like what we got multiply, add, this. Wait, isn't there, you know, we do one of the logical expressions, I guess, where comparator or something. Not just math, logic. Good. Yeah. Wait, ping pong? How would I? What do you mean by ping pong? Like, how would I mean, like ping pong? Something like teenage. Cool, nice. I'm good on you. Oh, if you bought these, there's also a bunch of free ones that are available up on the forum. There's like, it's like 600 articles or something that were collected. It's like all the free ones that are on the website that are collected together in one zip file. They're really enlightening, and especially since all of the block diagrams that you see in the Electro notes are things that you can translate directly into Audulus. Almost one for one in most cases. You know, like a VCA is just a multiply node, right? There's correlations like that. So I guess I'm going to go make another one that is, so it's 1, 2, 3. Let's do, just so I don't have to keep doing all, this is kind of boring and tedious doing all these controls. I'll have the rest of these be logical expressions in the way that they interact with the other ones. So just like, you know, trigger kind of style stuff. Math, logic. We can do the XNOR. Okay. Yeah, yeah. I forget what. Maybe Robert, if you know what forum topic it's under, I forget. I might have just posted it myself as a separate topic, but I can't remember off the top of my head. Okay. Get one of these. And yeah, but I don't need the other stuff. So what we're going to do is we're going to set this as 0.5, just like that, and I'm going to bring that XNOR in there. Whoops. There we go. There we go. And then just because most triggers take 5 volts, and I don't know if some things could be damaged by 10 volts if it's expecting 5 volts. Just having this halfway there will turn this 0 to 1 into 0 to 0.5, and then that will make the output at most 5 volts. And then I don't need this expression anymore, so we can get rid of it to save some CPU. And then we'll take this to output 4. And there. So, what was that? That was the XNOR, right? Yeah. Okay. Is A greater than 0? If it's greater than 0, it's an A. Otherwise, is B greater than 0? Huh. Interesting. Okay, well, I guess I'll reserve output 4 for that, and then I'll put this stuff up over here. I'll go back and do that. Let's switch this over. Output 5. Did that take? No. Okay, so you see I switched it to 5. That's going down there. Yeah, I know. I was just trying to figure out how, like, how can I show all of this stuff at once, but be light on my computer's weak graphics card. Okay. Expose. This again is I'm forcing them to go over here so I can distinguish them between these ones that go with this control up here and these ones that go with that. So XNOR. Do something like that. I don't know, maybe. There's a part of me it's just like I want everything to line up. It'd be nice to have guides or auto lining. There we go. 1, 3, and let's have a little light. That's all we need for the display there. Oh, hey Taylor. If y'all didn't know, Taylor is the creator of Audulus. So he's popped in. Oops. So if you're just joining us, what I'm making right here is a multi-utility module for the ES-8. And so this is the ES-8 right here. Audulus is plugged in from the computer going into here. It's a audio interface. And you could also just load this patch that's on the computer and load it on your iPhone and plug it into here with the camera connector kit. And we have 4 inputs for different CVs, and I've got 2 oscillators from the Mordax data, an envelope coming from the oscillographic block, and then I have a self-resonating filter that's coming from the 2HP filter over there. And then these are just acting as different oscillators to do different things. And so right now this is the multiply output, and what you can do is you can select the different inputs that you're multiplying by. So like right now it's squaring input 1 by itself, and then if I do this, then it's 1 times 2, and then if I do this is 1 times 3, and then this is the output over here. And then these little controls here, I can offset it negative and positive voltage, and then I can also attenuate it. So that's what we're doing for each. So this is multiply, add. This is a logical expression here that Robert requested. I'm going to do another one that's beneath this one, but just to speed things up, I'm going to do some other fireworks. more logical expressions here for rhythm stuff. Cool. Interpreter. So again, this is really easy. All I need to do is copy and paste that, and we'll pick a different logic one. XOR. No, let's do. You can, of course, if you go back later and you want to change these to something else, you can put little different logic modules in there. Let's do NAND. I guess that's just the inverse of that. Let me see. What did I do for this one? 0 is greater than 0. That one might not work very well. Okay. Maybe I need some other ideas here. I feel like not's not gonna really do much. Let's just do this greater than or equal to. Cool. This goes to 6. Equal to. Put those down. Yeah. Oh, nice. Have a good one. Yeah, the rest of it will be up, archived online when it's finished. So you can always check back in. There's also going to be, for every live stream video that I do, there's going to be a forum topic where I'll post all this patch stuff that we do, and then there'll be discussion about the patch that's made and all that kind of stuff. So, and whatever's the latest live stream will be pinned to the top. Maybe the latest couple or something. Let's see. Okay, edit UI. Oh, yep. Robert is referring to the scalable vector graphics. I think that's what it is. Utility. It's, if you go, it's right there. And then you can load different little shapes, just little graphics that you want to add to your patches. So they came up with some cool like wave shape, shapes basically that look nice, and you can use them as little indicators and things. Okay, I'll line that up. There we go. There. Cool. cool. Okay, and then I'll go back and I'll make this other one that, this ping pong one that Robert was talking about. And all I have to do is go find that expression that he would typed in there and just plug it right in. Just copy. And what's nice is, even though, you know, it's a whole different expression, they'll still stay connected when I press OK, because you're not renaming the variables. So let's see what this one looks like on different stuff. Oh, cool. Oh, I see. So yeah, okay. Neat. Offset it too. And what was this one again? That was that. Okay, and again, I'm turning all these down so I can tell that they're different from these ones, and then I'll just go 1, 2, 3, 4. And when I come up here, I can tell that's the one there. Put these back. There and there. Whoops. Whoops. There we go. So 1, 2, 3, 4. And this one's down here. And I'll line these up again. That looks like I had that off. Whoops. Oh, I guess I never spaced these ones, did I? Actually, you know what? I don't need to do the whole thing. I can just count the spaces in between. So that's 1, 2, 3. Wait, whoops. 1, 2, 3, 4, 5. So 5 down. So 1, 2, 3, 4, 5. That doesn't look right. Must be 4. Okay. Yeah. And then plug a 1 in here. And I think it's there. Right. Oh. Let's see. What's this? Oh, cool. Yeah. Nice. And this stuff goes here. Down there. Let's just call this ping pong for short. That way everything will line up too. That's what I did wrong. Okay. This was 1, 2, 3, 4. 1, 2, 4. This goes up 1. Sorry, I know this is boring, but it just ends up, you get a really nice looking module afterwards. Okay. So 5. I think I did that almost perfect. I know. Like that. Yeah. Okay, so I don't think I changed this one. Yeah, to 4. So now we just have 2 outputs left, but we got all of this, crazy LFO action, control signal stuff going from just one, these 4 inputs. So you can get a lot more out of whatever you're doing. Okay. Cool. Ping pong. Oh, I guess that's because that one's not negative. Cool. Do that. Kind of looks like a paintbrush or something. Okay. Saving that. Then, here are the last, just the last 2. Oops. Let's think of what this one should be. Robert or someone else, you got a cool logical expression or something in mind that could combine these? Oh, might as well have a rectifier. I mean, no. Yeah. So, no. Well, absolute value. I double clicked on this input there, and then that'll just automatically create a expression node rather than having to go menu diving and then find it. Value x. So that's no, what the absolute value of no. I think this might be similar to one of the other ones. Is that? Because I'm just waiting on some. It would be nice not to have to just especially since I don't want to make this so big. It would be cool to have 4 inputs or for LFOs combining them and doing different things, and then the other 4 or 4 logic, gates on and off type stuff. Okay, I see. That's interesting. Oh, there must be a... Oh, missing parentheses. There. BA. SS mode from a noise engineering module. Did I get that? Is that right for the, parentheses? Oh. Oof. Oh. Let me just, yeah, okay. Well, let me, I'm just going to go ahead and make some, just make these into other expressions that do just gates, just to finish this up, just as we don't have to drag this out any longer. It's basically, people are getting the point here. We could do just another logic expression. Say A equals... This might not happen very often, but let's see when they're both exactly equal. Yeah, I doubt this is cool. Going through a wave folder. Yeah, I've been talking about this module in terms of LFOs coming into here and turning into more control signals, but Robert has a point. This stuff you could easily make these into different oscillators that have crazy different tones coming out of them. So it's not just limited to control signals. But it looks like exactly equal is probably not going to be a good one because they need to be right on exactly equal. Actually, let's do something fun here. We can actually, what we can do is, yeah. Okay, we'll round these inputs or truncate them near the hundredths place. Let's see if that works. And this will give them some time to be exactly equal. Yeah, there we go. So what I did there was basically, you got these two analog signals that are coming in. They're turning into digital 32-bit numbers. And the time where two 32-bit numbers would be exactly equal to one another is minuscule. And so if you just have them, going like that, then this is never going to trigger. But if you round it off, then you get these little, there's more time for something in the hundredths place to be exactly equal to each other if you disregard everything that comes afterwards, and then that gives it time to become a trigger. And we're going to change this to 7, and whoops, not 67, not there yet. Okay, cool. I'll probably, let's do the tenths just to make it last a little bit longer. And all that's in here is just an expression that goes, the floor expression. So you take the input, you multiply it by 10, so it shifts the whole number over. So if you have like a 1 followed by some digit there, it shifts the 1 and the 0.1 over, and then you divide it again, which shifts it back after it cuts off the remaining digits. I'll just show you how that works. So it turns it into 1.1. If we just get rid of the divided by 10. So it's shifted these two numbers over. If we go to 1, like that. Okay. 1, 2. So if you notice down here, this stays lit longer, and might be more useful to some modules that need a certain amount of on time to get that loquelic iterus. I love this company. I forget was it Noise Engineering? I can never like say their module names. They're all in Latin. Okay, so we don't need this. Do exactly equal to. This is like computer science language, or like Boolean logic. You know, this means exactly equal to. This is greater than or equal to. There we go. That about it? No, because it's over there. Shift everything over. There we go. So it goes right here, down here. This must be 3 and 1. I can tell because this is, yeah, whatever. I'll line this one up again. Sure. That. There. Exactly equal to. Okay. And we'll do one more. Again, I'm unexposing and exposing these so that they'll end up in the, this is basically the 0, 0 origin point of this subpatch. Everything in the underlying code, everything has a coordinate to tell Audulus like where things are. And when you just copy and paste something, it'll have the same coordinates of wherever you copy and pasted it from. So if you unexpose it and expose it again, it'll end up at that 0, 0 point. So you don't have to like go hunting underneath things. Okay. And I just know those are the old ones underneath. And then I go here to check. Yep. Yep. And this one goes to output 8. And let's do another, let me see, another logical expression. Okay, that'll be fun. Does not equal a, what am I doing? What am I doing? There we go. I think this might be better if I round it differently. No. Why is that? I don't know. Whatever. Right, how does the... Is it... Yeah, in front. Oh, I'll have to go back and change all these because I'm just like everything to match up like that. But for the sake of right now. So, you know, there you have it. This is how you make, you know, an Audulus-based ES-8 module. And I don't know. Let's put a title on the module. Usually, like, whenever I put a title on a module, I always try to put it up at the top and in the middle so people can find it when they're inside. We go to let's see, what do you call it? Can't call it maths, obviously. But we call it math class. Let's do that. Mutable instruments, name this module. Oh, they would they probably do some, you know, Indian based algebra thing, the discovery of zero, I don't know. Deltas. Oh, well, yeah, well, maybe. Expose. There it is. Let's put that up at the top. ES-8. Oh, what the hell? Get the branding in there too. Expert sleepers. Guy runs Expert Sleepers, Andrew, or Os, as most people call him. Great guy. You know, he comped me this ES-8, but it wasn't actually this one. It was, you know, one where like he had some problem with the USB that he hadn't worked out, and it caused a short and failed. He sent one the next day, overnight from England. And like got me another one again. And I'm sure he has, you know, similar awesome customer service experience with individual people too. Even though I think he, you know, he does most of his stuff through dealers. But anyway, there it is, an ES-8 module that, you know, you've got 4 inputs here for your CVs, and you have all sorts of different outputs that you can then use to modulate other things. Maybe, you know, like later I'll make a video with some sounds and stuff. The audio routing is complicated with the video streaming and the ES-8 turned on at the same time. So, you know, I'll have some other video that shows me using this stuff. And of course, you know, I can maybe make a module version of this where it works in Audulus, where you don't have to have the ES-8. I like having that kind of version, so people who don't have one or don't have one at the moment and are doing one later, or, you know, they just don't have one and never get one, they can still use these cool modules altogether. Yeah, he totally does. I didn't get a free ES-8. I got one. I do a lot of, you know, advertising and work, you know, on the ES-8 in the sense that, you know, it's a lot of time making these modules and tutorials and things, so he gets a benefit from that too. It's definitely a two-way street there, but it was, you know, mutually beneficial in that sense. So let me see. Yeah, I'll post this up on the forum as soon as I'm done with the stream. You guys can download it, make your own versions, have different expressions there. But would love to see any videos, sound clips that you make, songs that you do using this module. And I know this just sort of struck me as like, oh, well, like I should do that while I'm thinking of it. I sat down and just started a live stream. But I'm gonna schedule a live stream in the future where I do like an intro to synthesis. It's the people who are still here might not need this this much of a basic intro tutorial, but this is going to be for like absolute beginners who like don't know what an oscillator is, don't know what a filter is, and or you know, people who are brand new to Audulus too, it might be helpful for you to see how everything like works at the most basic level. But I want to do, you know, a live stream series of, you know, just absolute beginner stuff that I can answer questions while people are you know, as I'm going along. So that's it, and thanks very much for tuning in, and I'll see you guys in the forum. Have a nice day.